In this lesson, we would understand what is the second derivative test and the concavity test, and how can we use second derivative and concavity test towards making the graph of the function. Learning goals for this lesson would be to understand and apply the second derivative test, as well as to understand and apply the concavity test. The success criteria for this lesson, after going over this lesson, would be that students will be able to know that the second derivative test is when the critical numbers are used in the second derivative function. Students will be able to make the interval table for the second derivative of the function. Students will be able to use the interval table to find where is the graph of the function concave up and concave down. Students will be able to understand the meaning of concavity of the graph. Let's understand all this with an example. Let's say we're given a function fx is equal to x cubed minus 3x squared minus 9x plus 3, and we are asked to perform the second derivative and concavity test on this given function to turn it into a graph. The first step towards doing that is always to find the first derivative. The first derivative of this function would be 3x squared plus 6x minus 9. The next step is always to find the critical numbers, because everything works around critical numbers. To do so, we would put the first derivative equal to 0 and we would solve this equation. In this, we would be using factoring technique to solve the equation. So since we have 3 times 9 is 27, the product that we're looking for is negative 27 and sum that we're looking for is plus 6. So we would break 6x into 9x minus 3x. When we simplify it further, we are able to get x plus 3 minus 3x plus 3. This would give us 3x minus 3 and x plus 3, and that is equal to 0. Since we have the factored form equal to 0, we would now solve for each x value. So in this case, we would get a 1, and in this case, we would get a negative 3. In this, we get to know that we have two critical numbers. One is 1 and the other is negative 3. So critical number 1 is negative 3 and critical number 2 is 1. We would keep these critical numbers on side, and now we would be finding the second derivative of this function. Second derivative is just the derivative of the first derivative. Since the first derivative equation is this, the second derivative would be 6x plus 6. Now let's understand what is the second derivative test. Second derivative test tells us what happens. As we already know that critical numbers are the x values where we see either a max or a min or a point of inflection that we just understood in the previous lesson. The second derivative does an extra job for us. That is, it tells us which critical number shows us a max and which critical number shows us a min. How does it work is, we just use the second derivative equation to sub in the critical number values in there. This gives us a negative 18 plus 6, which is a negative 12. And when we sub in the second derivative the other critical number, that is 1, we get 6 times 1 is 6 plus 6 is a positive 12. So always remember, the critical number at which the second derivative gives us a negative value, that critical number would show us a maxima point. Whereas the critical number that gives us a positive value in the second derivative would show us a minima point. Therefore, we can say at x equal to negative 3, we see a max, and at x equal to 1, we see a min. Let's understand this with an example. Let's say we are given fx is equal to x cubed plus 3x squared minus 9x plus 3. The first step is always to find the first derivative, and that would be equal to 3x squared plus 6x minus 9. The next step is always to find the critical numbers. For doing so, we put the first derivative equal to 0. Therefore, this equation would be equal to 0, and then we would solve the equation. For that, we first turn it into a factored form. When we do so, we would first multiply 3 and negative 9. Since we get a negative 27 as the product and we need the sum of positive 6, it would be plus 9x and minus 3x. That would be used to split 6x. When we factor it further, we are able to get 3x out, and that gives us x plus 3 minus 3. This gives us x plus 3 again. So the final factors that we have is 3x minus 3 and x plus 3. The product of these two factors is equal to 0, and we use each of these to find the x value. X is equal to 1 and x is equal to negative 3. These two are our critical numbers. Therefore, we write down the first critical number as negative 3 and the second critical number as 1. As we know that the critical numbers are the numbers where we either see a max, a min, or a point of inflection. This we understood in the last lesson. Now we would find which critical number gives us a max and which critical number exactly gives us a min point. For doing so, we would first find the second derivative, and this is what is going to be called the second derivative test. The second derivative of this function comes from here, so this is 3 times 2, 6x plus 6. To conduct the second derivative test, all we have to do is just plug in the critical number into the second derivative equation. So we use the second derivative equation of 6x plus 6 and sub in negative 3 in the equation. We get 6 times negative 3 plus 6 is a negative 12, where when we substitute 1 in the equation, we get 6 times 1 is 6 plus 6, which is 12. Now what does the second derivative test help us determine, and how does it do it is, whenever the second derivative gives us a negative value, then at that critical number, we would always see a max point. When the second derivative function gives us a positive value, then at that critical number, we see a minima point. If just in case it would give us a 0 again, then that critical number will be called a point of inflection. If in case, when we sub in the critical number into the second derivative, and it does not give us a positive or a negative answer, and it still gives us a 0 answer, then we cannot conclude anything from the second derivative test, because then the second derivative test fails. So we would just use the first derivative test as learned in the previous lesson to make the sketch of the function. Let's conclude all this. So second derivative test is when the second derivative at a critical number gives us a positive value, then that critical number is a minima point. When the second derivative at a critical number gives us a negative value, that critical number is a maxima point. If the second derivative at a critical number gives us a 0 value, then the second derivative test fails, and we use the first derivative test to sketch the curve of the given function. Going back to the same example, we now know that the maxima would be at x equal to negative 3 and minima would be at x equal to 1. To find the point where we see a max and to find the point where we see a min, we would just sub this x into the original function and determine the y value, and we get a 37. Then we solve for f of 1, and the value of y that we get at x equal to 1 is 5. Therefore, the max point coordinates are negative 337 and min point coordinates are 1 and 5. If we want to plot this graph on the grid, we would plot the max at negative 337. Let's say this is the point, and we would plot the min at 1, 5. Now we notice here that just by doing the second derivative test, we cannot make the graph of the given function because we just determine the maximum and the minimum point using the second derivative test. However, we can use the second derivative test along with the concavity test, and together the second derivative and the concavity test would help us to complete this graph. Now let's first understand what is concavity test. Concavity test helps us determine where is the function concave up and concave down. Let's understand what is the meaning of concave up and concave down is when the graph is opening upwards, like in this case, be it this or this. These are the examples of graph being concave up. When the graph is opening downwards like this or in this direction, this is all the example of concave down graphs. Once we know this, we will then be able to make the graph. To complete the concavity test, now let's understand what is concavity test. For that, we need the second derivative of the given function. So that would be in this case 6x plus 6. Then we put the second derivative equal to 0 and solve for x. That would give us a negative 1 here. We use this x equal to negative 1 to find the intervals and make the interval table. When we put this in the interval table, we get negative infinity to negative 1, x equal to negative 1, -1 to positive infinity, and we write down the values of the second derivative and then make a conclusion for the original function. When we sub in any value from -infinity to -1, for example -10 in this case, 6 times -10 is -60 plus 6, we get a negative answer. When we sub in -1 here, we get a 0. And when we sub in any value from -1 to positive infinity, that is a 0 in this case, we would get a positive answer. Since when the second derivative is negative, you have to remember now what is the concavity test is. When the second derivative is negative, the original function is concave down. When the second derivative is positive, the original function is concave up. And when the second derivative is 0, the original function shows us a point of inflection. Since we're given the original function, then we can find out the point coordinates of point of inflection. So all we would do is just sub in the original function -1 in place of x, and we're going to get a 21 here. Putting all this together, since we now know the point of inflection, it's -1, 21. We will plot that point of inflection here, -1, 21. Let's say 21 is somewhat here. Just to put it all together, the max point is -337. Point of inflection is -1, 21, and the min point is 1, 5. The graph is concave down from -infinity to -1, and the graph is concave up from -1 to positive infinity. We would use all of this information to complete the graph. So our graph would be concave down up till here. Here it shows the point of inflection, then go concave up with a minima at 1, a maxima at -3. And this is how our graph is going to look like for the given function. This is how we sketch the graph of a given function using the second derivative and concavity test.